In this section, we're going to take a look at weak acids and weak bases, as opposed to the strong acids and bases that we already talked about. Since we know what a strong acid is, then we can figure out what a weak acid is by how it dissociates in water. So a weak acid is one that ionizes only partially, so it does not split completely into ions when put in water. In fact, most of the acid is going to be intact. So if we took a look at this reaction here, so we have hydrofluoric acid put in water, we will have a little bit of ionization where the HF gives that proton to the water and it leaves behind the fluoride anion. So we have F minus and H3O plus. If we were to zoom in and look at this solution and what is happening with the molecules, we will see that most of the acid remains intact and only a little bit of it actually splits apart into the F minus and H3O plus. That makes for a weak acid, not very many ions in solution. We then use the double arrows to indicate this partial reaction or partial ionization. So we basically we don't have the reaction going to completion, meaning that all of it will be split up into ions, but we have a little bit of all of the above, all of these species. Here are some common weak acids, hydrofluoric acid, we just saw, nitrous acid, so HNO2, as opposed to HNO3. So HNO3 is actually a strong acid. Don't confuse the two. Formic acid, HCOOH, benzoic acid, acetic acid. If you are familiar with acetic acid, this really is vinegar, so this is what gives it that acidic taste to the vinegar. But there are way too many weak acids, a lot more weak acids than there are strong acids. So if you figure out or keep a list of the strong acids, everything else is going to be weak. So here's the list of the strong acids: HCl, HBr, HI, HNO3 compared to HNO2, but HNO3, HClO3, HClO4, and H2SO4. These are strong acids, so anything else is going to be weak. And that is just an easier way to remembering what is a weak acid and strong acid. Weak bases, the similar idea here, do not ionize completely in water. Ammonia, for example, so here's the reaction. If we place that in water, just a little bit of the water is going to donate that proton to the ammonia, and it's going to form NH4 plus and OH minus. But if we were to look at it molecularly, most of the base molecules are going to be intact, and a few of them are going to accept those protons. That is what makes a weak base. Those that do not completely ionize in water they're going to mostly remain the way they are. Here's a list of some common weak bases as well. Ethylamine, here's the formula, methylamine, CH3NH2, ammonia, we just mentioned, NH3, pyridine, this is a base in our DNA, aniline, dimethylamine, so all of these are amines and they're weak bases. Once again, there's a lot of weak bases to memorize. So here's the strong bases. So once you kind of have a clue what the strong bases are, anything else is going to be weak. NaOH, KOH, RBOH, CSOH, LiOH. Well, guess what? These are group 1 hydroxides. Those are very strong bases, very strong. And then here's some group 2. Calcium hydroxide, strontium hydroxide, and barium hydroxide. So these are all group 2 elements, and these are group 1 elements, and they make for very strong bases. So anything else is going to be a weak base.